Hello, everyone. My name is Khairulla Aben, and I will be the presenter today. Um, the topic is called optimization of the drilling and blasting process to improve fragmentation by creating preliminary stress in the block. It's very important to say that this work was conducted in cooperation of researchers from Kazakhstan and Ukraine. You can see my colleagues and co-authors on the screen. The structure of the presentation is very straightforward. I will start with a short introduction, then we'll have a discussion of the potential technologies, then switch to research methods that we have used in our work, and the site where we have conducted several experiments. Then we'll talk the proposed technology, and finally get to the results of the work that we have received. As you all know, the mining industry is very competitive and requires mining companies to perform very well and implement new technologies every time to cut the costs, improve efficiencies, and improve the safety. And we have narrowed down basically the research topics for ourselves and have selected mines with heap leaching technology or processing. Such mines have different parameters which affect the costs and overall efficiency, of course. In our case, we have selected a characteristic which is very important, which starts at the mine and affects every downstream process and cost. The parameter is fragmentation. It is a very important parameter for any heap leach mine because the size of the ore the pieces of ore that you put in the heap leach dramatically affects your metal recovery at the end. And of course, it could increase the costs as well. The reason why it increases the costs, because if your rock size is too big, then obviously you need to put several stages of crushing, of mechanical crushing. Normally it is at least 3 stages to get required piece size. And of course, such crushing, mechanical crushing using jaw crushers or cone crushers can make from 8 to 18% of the total operating cost of the enterprise. By saying total cost, I mean that it could be 8 to 18% of the cost of mining and processing and admin costs and everything all together. So that's a quite high number. And of course, everyone understands at the same time that cost of ore fragmentation during drilling and blasting operations is normally significantly cheaper than mechanical crushing. So our research was aimed at that. We have tried to improve fragmentation during drilling and blasting process. Overall fragmentation with blasting is a very complex process which not everyone still understands, and actually there has been a lot of research works conducted, but none of them explains it in every detail, basically. So if we imagine an unlimited homogeneous medium, then in that medium the blasting would go in several basically stages. Initial stage would be shockwave generation, then it would propagate and create a compression stress in rock, which would increase very quickly, and then particles of rock would be displaced radially by cracks created. And then obviously after the shockwave passes, the pressure would drop. Schematically, look at it. if you have a dual blast hole in the center, charged blast hole, which is shown as a white point, basically white round in the center, then you would have uh, three zones of deformations. The first zone, which is red on the picture on the right hand side, that's the zone of plastic deformations. Obviously, in this area you would have the highest stress and the highest fragmentation of rock. That's the area where you have plastic deformations. Next zone would be a zone of elastoplastic deformations, and the last zone would be zone of elastic deformations, which would be actually least affected by the blast. If you imagine blasting process in a block, and here we have just schematically shown a small block consisting of 4 blast holes. Basically, these are blast holes. Obviously, the process would go the same way, and the closer the rock is to the charge, of course, the more fragmented it would be after the blast. And the further you go, the less rock affected by the blast and less fragmented, of course. So here we have schematically shown a point between all the holes, which is the center of the block in this case, and this area is the least affected by the blast, and obviously it would have the worst fragmentation. Now, in order to conduct the research, knowing that there are some areas in every block which are least affected, we have gone in 2 steps. First of all, we have done some numerical calculation of how to improve fragmentation in such areas. And then we have conducted actual experimental blast in an open pit here in Kazakhstan. Talking about the open pit itself, I can say that it's a gold mine. It's a gold mine which with a relatively low gold grade of 1.4 grams per ton, and it is a setup operation. It is operating. It's up and running, and what we have done is just we have to propose new technology, and we had the results before the proposed technology and with the proposed technology, which we'll discuss later. So we took all the parameters that they have, the actual ones. You can see all of them in the article that we have published, and we looked at those areas that are least affected by the blast and have proposed a technology. So currently they have a square basically shape of the blast holes formation in the block. And what we have proposed is to drill intermediate row of blast holes in the centers of the blocks and create so-called initial stress in the block. So basically, that would mean that we would blast these holes before the main charge would be blasted. We have done some calculations so that the blast of these holes would not affect the remaining block, the remaining charges in the block. Again, details you can read in the article. And it's quite important in that we have set certain goals for ourselves to get certain results, and I have to say that the actual results that we have received, they have exceeded our expectations. And after proposing that intermediate row of blast holes with certain charge to create a preliminary stress, we have realized that fragmentation in the blocks have actually improved from the blast that the mine had before by approximately 25%. Of course, we have done some calculation of the time and costs that are required to drill that additional row, and those would be between 15 and 20%. So obviously you would have something around 7 to 8% difference. And of course, this technology is very promising, and in order to do full-scale calculation of the economic effect, we would need to put a separate heap leach and calculate all the downstream costs and calculate the NPV of the technology, which we are planning to do hopefully this year at the same mine. That's it from my side. Thank you for listening. For more details, please read our article and where you can see all the formulas. And if you have more questions, please contact myself or any of the co-authors. Thank you.